Hi there, I'm Rick, a co-founder at Dot, a startup that helps build a data assistant for data teams. And in today's presentation, I want to explain to you why text to SQL is solved and what are the next challenges. So let's get started. If you don't believe me that text to SQL is solved, I want to give you two examples. Then we walk you through a short high-level view on how you can think about the space, and lastly, we dive into the challenges. So let's say we have an e-commerce shop where we have a typical orders table, order line items, and so on. And we are asking a question: what are the top 5 most sold products last year? I'm going to show you an example of how Dot will basically perform this query, but there's actually a lot of other startups attempting similar things, and also some open source solutions. The devil is always in the details, but if you use state-of-the-art techniques today with retrieval augmented generation, guardrails, and so on, you basically get reliable results. And here I just want to walk you through all the things that GPT-4 or other frontier model-based solutions can do today. So to answer this question, we get an explanation with a rather complex SQL statement, and now let's just go one by one to see what is needed to answer this question correctly with SQL. So the first thing that it needs that the model or the assistant needs to be able to do is to map the business meaning to columns. And as you see here, there's no direct mapping, right? Like we have we ask for products, but we actually pull a column called name. We ask for most sold items, and it's actually pulling quantity. So the next thing is it needs to be able to filter for the correct time frame. We see that in the where clause. Also, it's correctly aggregating a measure with a sum. A sum is obviously easy, but there's a lot of other aggregations that also work really well. One rather advanced thing is it's able to join 2 tables on a correct key. That's something a lot of junior analysts actually make a lot of mistakes on. And it also applies a relevant filter to filter for business logic. So when we're asking for the top 5 sold products, we obviously only want to look at products that were successfully shipped to a customer, so they have a status complete, they are not canceled or anything else. Now that it can do all of that, you're not surprised that it can also use the order by clause correctly, so it orders by the calculated values, and then limits the result set, so we actually only get the top 5 results and nothing more. So that's basically the first example. A lot of things in the SQL clauses that this thing is basically successfully able to leverage. In the second example, I want to show you something where we need to compose a more complex SQL statement, which basically means that we are able to answer this question not with a single select clause, but we need multiple. So how has overall revenue grown in percentage between 2 quarters ago and last quarter? To answer that, maybe if you have a chance to pause the session, even try to think about it. What are the things that are required? It's actually not so straightforward. It would be pretty hard for a practitioner to just write that in one go, but fair enough. These large frontier models are pretty capable of doing so. And the way it's solved here is basically with a multi-step calculation with common table expressions. A detail that is also worth noticing is it's also aggregating by the right time dimension in both cases, and it applies a correct formula on the fly, basically to calculate percentage difference, because we don't just ask for absolute values, but we want a percentage difference. So now these are 2 examples, but what it's telling is also that the leading text to SQL challenge from Yale, basically they got a lot of updates in the last 12 months. Because of large language models, and currently the top 5 papers, so the score got higher and higher. And the latest 5 papers with code basically use GPT-4 based approaches. Does that mean you can just plug GPT-4 on your data warehouse and expect magic to happen. So yes and no. As we know, if someone studied like something like high output management, or it's even more famous, garbage in, garbage out. To get good output, we need good input. And if we use the famous black box approach, where we basically, what are the inputs that we get? We get intelligence. In this case, it can be artificial intelligence. It can also be human intelligence. And we combine it with really good semantic data model. We can get out insights and recommendations. And as practitioners in the field, on the intelligence side, you can obviously only do so much. So one of the big areas for improvement to get better output is to focus on the semantic data model. With that being said, so what are the actual challenges now that we have an intelligence that is able to map natural language? By the way, doesn't matter which language, English, French, German, Spanish, it knows them all, to SQL. So the one challenge is that your data model is often incomplete when it comes to the meaning and how it maps to your data. So you need how it maps to your business. So you need to capture implicit knowledge in your organization. My hunch is that remote companies have an advantage here because they are used to asynchronous communication and they usually write more things down anyway. The next frontier is you don't just, like I said, you need a clean data model, but interestingly, obviously, these large models, they can also help you with that. From an easy form of like just a really sophisticated auto-completion with something like GitHub Copilot, to something that would be called maybe documentation first data flows, where you say what you want. The model is producing that for you, and then you audit it, say that's right, and you just put it in production. Further down, we can also obviously think of more multi-step and even bigger problems, especially on standardized data sources, where you can just say, I want to track the 10 most important metrics for my B2B SaaS business. The data comes from Salesforce, just do the rest for me. For really custom business data models, I think that will probably take a longer time because it's pretty hard to formulate that. But for standardized source systems like HubSpot, Facebook, and etc., even if you then also use a standardized connector like Airbyte, that will soon start to work pretty well. And then the last one, less focused on the input space, but more on the output space. Obviously, visualizations are a low-hanging fruit here to just not just get the data back on the SQL statement, but to basically get it visualized. That's something we also do with Dot, for example. And then the next step is really that the agent has more domain knowledge, business expertise, and can also recommend actions and put things into perspective. So in our e-commerce example, it would be nice if it can not just calculate the click-through rate, but it can also say like, oh, this is a pretty high click-through rate given your industry. So well done, or oh, it's pretty low. So probably there's a bunch of areas where we probably have high leverage to improve that. So what can you do today, given the current situation? Just high level, test and invest. Test AI agents. They are already a big productivity boost, and it's also, to be honest, just interesting to learn about them and to see what can they actually do. And then the second piece is invest in good information. This is the foundation for any intelligence to take good decisions, to come up with insights. I would be happy if you check out what we are building with Dot, which is specialized for data teams. But if you're more into open source and you want a general purpose approach, there's LangChain, if you have not heard of it, where you can do a lot of where you basically have a complete layer on top of large language models that you can play around with. When it comes to investing in good information, I would recommend to like kind of audit what you currently have in these 6 buckets. make sure you capture the data that you really care about and you capture it well. Integrate this data into a common place so you can easily combine it, and it's easy to access in a central place like a data warehouse. Model your data, so it's not just the raw data, but there's some intelligence on top of it already integrated that makes it easier to consume it. Measure if it's of good quality. Document what it means, how it relates to your business, and maybe even implement a technical semantic layer. The semantic layer can to a certain extent live in your documentation, but there's a place also for a technical semantic layer, for example, for your most important business KPIs. All right, that's it. Thank you for processing my tokens. And if you have any questions, feel free to reach out.